Now let's take a minute to recap what we've just learned. If you were to take and add a positive constant to the squared term in the equation y equals x squared, you know that will have the effect of moving the graph vertically upward a given number of units. If you subtract a positive constant from the squared term, it'll have the effect of moving the graph down a given number of units. Now let's see what happens next when we subtract a positive constant from x before squaring. So we're going to take a look at the equation y equals x minus 2 quantity squared. Now I'd like you to take a moment to think on your own what effect you think that will have on the graph of y equals x squared. Now, before we fill in the table below, let's take a moment and play detective with the equation. Now you can see that we're subtracting 2 from x and then squaring to get the output or the values for y. Now that'll tell us that in every case the value of y will be positive except for the one case where the value of y will turn out to be 0. So that will tell us that all the points except for the one point where y is 0 will be above the x-axis or in quadrants 1 and 2. Now I'd like you to pause this lecture for just a moment and to compute the values for y that should go in the table. Now you can see that the values for x in the table are those that we've used in the previous two examples, except for the additional value of 4 that I've tacked on at the end, and I think that point will be particularly useful when we graph this specific function. So now what you might do is again pause and take a moment to sketch this graph and see if you can determine if the graph was changed in the way that you thought when you first looked at the equation at the beginning. Now what I've done is to graph the points in the table, except for the first point, negative 325, just because the y value is a bit too large for the grid that I've created here. I've also added a couple of additional points beyond the table so you can get a complete picture of what the graph really will be. And also note here that on the y-axis, and let me state this here so we don't forget it, that on the y-axis, each block in this particular case represents 2 units. Now, is the graph in the position that you thought when you first looked at the equation in the beginning? Now you can see that the vertex for this graph is located at the point 2, 0. Now remember that the vertex for the graph of y equals x squared was located at 0, 0. So it looks as though that graph has been shifted to the right 2 units. So let's state officially now then that the vertex for this graph has the coordinates then 2, 0. Now the axis of symmetry, remember, is the line that divides the parabola in half, and it will always pass through the vertex. So let me draw that in next. Now the axis of symmetry is the line that you can see that's drawn in green, and because it passes through the vertex, I think you'll agree that the equation for that line will be x equal to 2. Now for the domain, as with the previous examples we've looked at, it will be all real numbers. So we can then say in interval notation that the domain is negative infinity to infinity. And for the range, if we look again at the vertex, we can see that the y value of the vertex is 0. So it should be clear that for any other point on the parabola or on the graph, that the y value will be larger than that. So we can say then that the range will be from 0 to infinity, including 0. So to summarize, this example should show us that if you subtract a positive constant from x before squaring, it will have the effect of taking the graph of y equals x squared and shifting it to the right a given number of units. Now you'll be asked to consider on your own shortly what effect it would have on the graph if you add a positive constant to x before squaring.